Okay, so I was saying about this one. Do you remember this? We did this together. You have a question on this or no?
Yeah, how do you okay, how do you do that consistently? Complete the square. How do you complete the square?
Okay, so let me just give you a quick lesson for completing the square. Okay. If you
Mm-hmm.
have something like x squared plus 8x minus 5, what you do when you complete the square is you're rewriting this thing into vertex form by carefully choosing a number to add and subtract on the same side of the equation. And that number is half of this squared.
So
So
16.
half of 8 squared is 16. So I'm going to add it and I'm going to subtract it. Now the reason I do that is because adding that is going to allow me, what does that factor into now? What do those three things factor into?
4x4.
X plus 4 and x plus 4, or x plus 4 squared, right?
Yes.
And that's why it's called completing the square, because it allows it by carefully adding the right number, it allows you to write this thing as a perfect square in vertex form. And then of course you have to add these things as well together, which is going to be -0.1.
Oh, okay. So that's how
Do
you
you
get
see?
vertex form.
Yeah, do you see how this is vertex form now? This equation is the same equation as this, it's just written in a different form.
I see. Okay.
Okay. Now it gets trickier when you don't have a leading coefficient of 1, or when b is an even, then it gets a little tricky, because you're going to have to deal with a fraction, or you're going to have to factor something out. So look at what I did here. I factored out, see how I grouped these x terms together, and I factored out the -2. And then I took half of -4 squared and put it here. But then on the outside, I'm actually adding an 8. And the reason I'm doing that, not a 4, I'm not subtracting 4, I'm adding 8, is because really, what did I do when I put a positive 4 inside here? What did I really introduce to this equation? Because there's a -2 on the outside, what is this really like I'm adding to this equation?
-8.
A -8. So I have to add a +8 on the outside to offset it.
Okay.
Okay, makes
All
sense?
right. Yeah.
So 34, which one do you want for this?
Just 34, I guess. We can do the other two later.
Given a parabola with a vertex, so this is your vertex and that's your point. Write the equation of the parabola in vertex form. Okay. So the vertex, so my vertex form is going to be this: y equals a times x minus h squared plus k, right?
Yeah.
And this is
Oh, it's a
my
parabola.
h. Yeah, it's a parabola. That's my h and that's my k.
Oh,
And this is
I
some
remember.
random x, and that's some random x and y. So I already have what? I have h and k. What's the only other thing I need for the vertex form besides h and k?
X.
No, I don't need the x and y. The x and the y. Right? Look at this equation over here. That's in vertex form. There's my h and my k, and I also need this number, which is called what?
A.
That's right. So how am I going to find a? I'm going to use
Um.
x. I'm going to use x and y. I'm going to plug x, y, h, and k in, and I'm going to solve for a.
All right.
Okay. So what's my x? Or sorry, what's my y value?
Y is 9.
Good. And remember, I don't have an a yet, right? So I'm going to write a because I'm solving for that. What's my x value?
6. So 6 minus
What's
2
Yep.
squared plus 3.
Plus, yep. Good. So solve this for a now. That's
6,
16
19.
plus 3. No, not 19, because that's
What?
being multiplied.
Oh,
Those don't get added. The 16 and the 3 don't get added. Now, how do I solve that for A?
You divide.
Not yet.
You 3 over.
I subtract 3, right?
Yeah.
So 6 equals A times 16. And now what? What does A equal?
16. Yeah.
6 over 16, which is divide both sides by 2, 3
3
over
8.
8. So what's my equation in vertex form? Well, y equals
3/8 x minus 2 plus 3.
perfect. X minus 2 squared plus 3. Don't forget the squared. Okay.
Okay.
All right, it says find an equation of a quadratic function if the vertex is -3, 4, and there is a minimum. Well, if there's a minimum, then what does that mean about your A?
Your minimum, that means that it's going to be positive.
Mm-hmm. A is positive, so just write the equation with any A you want. Just make it a positive A, right? Y equals, let's just call it 1, right? X
Yes.
plus 3 squared plus 4. That would work.
Yeah. And it's the same with like well, not the same, but it's very similar with 36. It's just like y equals -1.
Yep, exactly. You got it. All right, moving along. Which one do you want on this one? 38?
38, yeah.
Well, you're probably good with this because we've already done it. Or no, you know what? Let's do it. What's the different ways you can find the vertex? Do you
You can
remember how you
do
find the vertex?
yeah, you can do completing the square.
You can, or you can use when it's in standard form. Do you remember how the vertex, the x coordinate of the vertex is just -b over 2a?
Yeah, that's
So
true.
it's -6 over 2 times 1, which is 2. So the x coordinate is just -3. And if that's the x coordinate, the y coordinate is just whatever you get when you plug in -3. So it's 9 minus 18 plus 7, which is -9 plus -2. Got it?
Yeah.
1, 2, 3, 1, 2. Okay.
So your y-intercept is 0, 7, obviously. It's
Mhm.
positive, so it opens up.
Yeah, and look, you can, now that you have this, you can just draw in your axis of symmetry, and you can find another point that's the same distance away as that y-intercept. So 3 away from that. You get what I'm doing?
Yeah.
Because you know it's going to be symmetric. And then the domain, you can tell, right? It's from -infinity to infinity, and the range is from -2 to +infinity.
All right.
Okay.
Yeah.
All right. Let's just do a couple of these and then we'll be done, because I think either someone else is coming in or, well, we're done regardless. But solving a system of inequalities like this,
You just do one of them. Just do one of them.
yeah, I'll do the hard one. Notice this is 2 quadratics, so you might have 4 solutions, right? It could be like this, and it could be like this, right? There could be 4 solutions, could be 1, there could be no solutions. It could be like one of them could be over here, and the other one could be over here steeper, so they're never going to touch each other, right? Well, no, they would still touch each other, I suppose, but they might only have one solution. Can you make one that, no, I guess if they both open up, they have to touch at least once, it seems. I don't know that that would be possible for them not to touch each other. Anyway, but there could be 0 solutions, 1 solution, 2 solutions, 3 solutions, or even 4 solutions, like something like this. No, not 4 solutions. I'm so sorry. What am I saying?
All right.
What am I
We
saying?
solve the problem.
There could be 2 solutions. Yeah, that's a good idea. Let's solve the problem. Trying to give you a visual, but maybe sometimes it's easier just to shut up and do it. All right, so let's multiply everything by -1. When I multiply by -1 on this bottom equation, it's gonna allow me to now, if I add the equations together, I'll get 0 y's and I'll get 0 x squareds and I'll get -10x and I'll get +10. So what does x equal?
1.
Good. And if x equals 1, then what does y equal?
-9.
Yeah, if
No.
you plug it in, you plug it into here.
Yeah, I think it's
So
-9.
-9 plus 1 is -8,
Oh, okay.
right?
Yeah.
Y equals -8. Let's check to make sure that's true. Let's plug in 1 here now. 1 plus 4 minus 12 is -8. Yeah,
Okay.
got it. So that's how we would do that one.
All right. Thank you.
Now, the instance that you're gonna have more than one solution is if you had like, if one of this had, if there was like a 2x squared here. Because then when you eliminate the y, you're not eliminating the x squared as well, you're only eliminating the y. So x squared, you're gonna have 2 solutions now
All right.
in that example.
All right.
Sound
Thank
good?
you. Yeah, thanks.
All right, man. I'll talk to you later this week, right?
Yeah.
All right, have a good one.
Sure. Thank you.
No
Bye.
problem. Bye-bye.